Okay, next lesson is about regression and the LSRL, which we have talked about but don't actually know what that is. So in LSRL, we consider that to be our line of best fit. So when we have our scatter plot, it's the line that, so I'm just going to draw a picture of our scatter plot. Beautiful. It's the line that makes the vertical distance from the data points as small as possible. Yes. So it's the one that is going to minimize all of the vertical distances. Now what it means when it says used to predict y values for any given x within the range of data, this is important because if I took a sample and I was measuring like hours of sleep versus your grade on the test. So I took a sample and I had a range where some people got 2 hours of sleep all the way to 9 hours of sleep. And then their grade ranged from like 52 to 100 or something like that. If I asked the question, what grade would a person make? So what is the grade if a person got 17 hours of sleep? Does that even make sense? Like, could I predict that? Technically I could put it into my y equals mx plus b. I could put it into the equation. I could get an answer, and I probably would get something really weird if it's going to be keeping up on this trend. It would probably give me something like 193. Well, that doesn't even make sense. Like, it isn't 17 hours of sleep doesn't happen, and you can't make 193 on the test. So when I say within the range of data, it means I can only predict x values between 2 and 9. And anything outside of those, like if I asked you to predict 1 or I asked you to predict 10, it wouldn't necessarily be accurate. It would be called extrapolation. That is a big word. So extrapolation is when, and this doesn't happen very often, but I mention it because if I said predict with 17 hours of sleep, that's not in my accurate range. So my line of best fit will only work for predicting between 2 and 9, and nothing outside of that.
So extrapolation is when it's not within the data range?
Yeah, exactly. So here's my LSRL. I gave you both of them, and this is the way that you'll see both of them. So it's really like a subscript 0 and a subscript 1, but when I copied it over, it didn't really work. It did it for y'all. Okay, perfect. Good. So when I have this y with a hat on it, that is my predicted y value, and I literally call that y hat. My b with a subscript of 0 or a, you might see it written in the calculator. It has a and b, but sometimes on tests and I think on your formula chart it's b sub 0 and b sub 1. So I have both of them. But that is your y-intercept. And then the b with a subscript of 1 in front of the x, that is your slope.
So it's x, it's not the intercept.
No, it's like the number in front of x is your slope, and then the number that's by itself, the constant, is your y-intercept. It's like just a line, like y equals mx plus b. Yeah, same thing.
A linear formula.
So what we're going to do is we want to take our data and we want to find our LSRL using our calculator. So what you'll do is take your bill, which is your explanatory variable, put that in list 1, and then your tip, which is your response variable, in list 2. I want you to write explanatory and response by them because we didn't talk a lot about it, but that's what they're called, explanatory and response. Now when you're doing finding the regression line, last class I said that you could either do stat calc 4 or stat calc 8 and it didn't matter. But from now on, we're always going to do stat calc 8 because it gives you the A plus BX. It gives you in the right order.
Okay.
If you do the 4, it gives you a different order, which sometimes gets confusing. So we're going to do stat calc 8. Once you get that, I hope that you get these numbers.
Linear rate.
So somebody verify that you got these numbers for me. You did? Okay. Your regression line, to answer this question, especially on a test, you also have to define your variables, what y hat and x are. And if you leave this part off, you get the question half wrong. So y hat is our predicted tip. And our x is our bill amount. So there's two parts to this. You need the hat. You can't just put y equals. You need the hat. You need the equation, and you need to define variables.
Oh, so for the second one, like for the next problem, do you just plug that 7, 40?
Yes. So then it says predict. So you just plug that in for x. And does it work? Is it within the range of my x values?
Yes.
So I could predict anything from what to what? 33 to 107. And anything outside of there, I wouldn't be as accurate. So y hat equals negative 0.347 plus 0.149 times 7456. And so what do you get? 1068?
I got 1076. That's what I got.
1076?
Yeah.
What I want you to do next is on the next page, I did figure out how to find the regression on Excel. So go ahead and get your laptops out. It wasn't under the data tab, it was under the tools tab or something. So this is called computer output. And sometimes, you guys aren't listening, sometimes a problem won't give you original data, it'll just give you this. And you have to know how to read it. So I'm going to show you, there's only 3 things that we need to circle on here, and the rest is irrelevant. So the first one is our r squared. So circle that. That is our r squared, which is our r squared. 0.686, okay? We don't need anything else from here, so you can either cross it out or just leave it, whatever. We don't need anything that says ANOVA. That's ANOVA's gone. That would be for something else, which we don't learn in this class. And then in the bottom, we look at this little box right here. The rest we don't need. Okay? So we can actually find our LSRL from this. And yours might say bill, it might be blank, or it might say X variable.
Yeah, that's what mine says.
When you typed in your data, if you put tip and then, or bill and then tip, like in the top 2, it's going to label it for you. If you just went ahead and typed in the numbers, then it doesn't fill it in for you. But it doesn't matter either way. The way we read this is we say y hat equals this negative 0.34, that's my intercept. And it actually has the word intercept next to it, so that's really nice. Negative 0.347 plus 0.149x, which should be the same answer that you got on the front, where y hat is our predicted tip, and then x is our bill amount.
I don't see data analysis is important.
The only thing that it does not give you on this computer output is it doesn't give you your R, but I can take my R squared and I can square root it. So in my calculator, I'm going to take 0.686 square rooted. And what do you get? 0.828. The only thing that it won't do is tell you whether it's positive or negative, because anytime you square root a positive number, you're going to get a positive answer. But your R is not always positive. So the sign of your R will always match what your slope is. In this case, our slope is positive. Our slope is positive here. So that means we have a positive R. On your homework, you're going to see an example where our slope is negative. So then I would just put a negative sign in front. Okay? So just make yourself a note that says your R will always match the sign of the slope. So if you have a positive slope, you have a positive R. If you have a negative slope, you have a negative R, but you have to add that in yourself. So those are the only three things that you need from there. The last part of this section is interpreting the slope and the y-intercept, and we have little scripts for them. So up until this point, we have two scripts, one for R, one for R squared. Now we have two more, slope and y-intercept. And then that'll be it for the scripts. So go ahead and write this one down, and then I will talk about it. Every single time you're increasing by 1 unit, your slope, like your y, will either increase or decrease by your slope. So think about it practically. If your slope is 2, that means you go up 2 over 1, up 2 over 1. For y-intercept, you have to decide, or you have to ask yourself two questions. Like, does the y-intercept make sense? No. Is it a reasonable value? You could just put, you could just put, go back.
It told you to go back for me.
No, not that far back.
That was common.
There we go. You have to ask, does it make sense?
Oh, we know that's you in English.
So let's think about our example, and we're about to do this in interpretation, but I will give you an example of why it doesn't make sense. So our y-intercept in this instance is a negative number. It's negative 0.347. So what that's saying is when my bill is $0, I'm going to tip negative 34 cents.
That does not make sense.
Does that make sense? No. So I would write, and we'll do that in a minute, but I would write the y-intercept doesn't make sense because, one, you don't have a bill that's $0 unless, I guess, if you order water, but you can't tip negative cents. So it doesn't make sense. So basically we explain why it doesn't make sense. And if it does make sense, then this is our interpretation. So if it doesn't make sense, we explain why. And then if it does, then this is what we put.
Wait, what does the second one mean?
Like, do any of your x values, are they close to 0, or are they all really big numbers?
Oh, yeah.
So we're going to go through interpreting all of our things we have found. So you guys need to listen carefully because you're going to be doing this over and over and over and over again. So the slope in this case is what number?
0.149.
0.149. That's my slope. So I'm going to look at my script, and it's for each increase in 1 unit. And so in this case, what is 1 unit? For every increase in $1. So for each increase in $1, basically when my bill goes up $1, my tip increases by 15 cents. So I'm tipping about 15%. The tip increases on average $0.149.
Can I write 14.9%?
You can put 15 cents or 0.149 cents if you want. Okay, the y-intercept. When our bill is $0, our we tip negative 34 cents. But we said that doesn't make sense. So I would say y-intercept does not make sense because you can't have a negative tip. I guess technically you could have a bill of $0, but you definitely can't have a negative tip.
Well, technically you can.
No.
I've
You
been
could
to a
steal money.
restaurant- No, I've been to a restaurant where they gave me my money back.
Yeah.
Sometimes they just add the tip with the bill.
Yeah, and I don't like that.
So your y-intercept is like when you're setting x to 0, that's your y value. So when x or the bill is $0, yeah.
Okay.
When my bill is $0, it's saying that I tip negative 34 cents.
So it's gonna be that first dollar.
Yes. Uh-huh.
And it was drawn.
Okay, my correlation coefficient is R, and what do I do to interpret R?
Oh, it's the stuff from last week.
It's that acronym that's your favorite, LSD. So I would say
Linear, strong.
there is a strong, what direction is it?
Positive.
Positive, linear correlation between X and Y. So what are my X's and Y's? Bill and tip.
Are you gonna count off? We put those in the wrong order.
No,
So positive.
Can anything be in like whatever order?
it can be in any order. Yeah. And my R squared is that funky percentage. Does anyone remember that? 68.6% of
Oh, hold
I
on.
wrote this like last night. I was in the house.
Tips.
of the variation in Y. So what is my Y?
It's the same as
And tip can be explained.
by the LSRL.
Perfect. By the LSRL.
Can I put those letters in whatever order?
No.
The LRSM.